Welcome back, great minds. So, I want to take a look at another aspect of number system, which is called fractional base number. Okay, this aspect is talking about when you have a decimal point. Okay, that means you have a fraction. You have a fraction as part of the number you want to transform into a different basis. Okay, so now let's take a look at this example. The example says convert 101.01 in base 2 to what? To denary base. Denary base simply means number in base 10. Okay? So now here we have solution. If you have 1011.01 base 2 to be converted to base 10, the first thing to do is that you should know that this particular question is in two parts. We have a whole aspect, that means a whole number aspect, which is 1011, is a whole number. Then this point 01 is the fractional aspect of it. So we're going to do it in two different ways. This whole part of the question has been learned already, but this fractional aspect has not been learned. Okay. Now, in order to do this fractional aspect, what you need to do is that, here's a hint. He said after decimal point, the power continue from -1, -2, and so on and so forth. Okay, so how do you apply this? Let's take a look at it. Look at this. So if you look at, you're going to consider them in a different ways. Okay, so then when you're done with them, you add them up. Okay, now this 1011 is going to be 0, 1, 2, 3. So the highest power of the base 2 is what? Is 3. You're using what? Expanded form. So you have 1 times 2 raised to power 3 plus 0 times 2 raised to power 2, isn't it? Plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. Okay, that's end the word, the whole number aspect of it. Then I move on to the fractional aspect, which starts from 0, or which continue from 0 rather. So you have 0 times 2 raised to power -2, as I said earlier, and -1. Okay, you continue from -1, the power is going to be -1, -2, and so on and so forth. So you have 0 times 2 raised to power -1 plus 1 times 2 raised to power -2. Okay, now when you do that, you have something like this. You know, you're subjecting the powers to whole numbers. So 2 raised to power 3 is going to give you 8, 2 raised to power 2 will give you 4, 2 raised to power 1 will give you 2, then 2 raised to power 0 definitely will give you 1, isn't it? Then 2 raised to power -1 is going to be 1 over 2 raised to power 1. Okay, 1 over 2 raised to power 1. So that means anytime you have a negative index number, it's going to be what? Inverse of the number without the negative sign. Okay, then the power becomes the power of the base. So 2 raised to power 1 is actually 1. It's actually 2, so there's no need of putting them 1 there. So you have 1 all over 2 raised to power 1, which is 1 over 2. So plus 1 times 2 raised to power -2. So here the power is more than 1, so it's going to be just 2 there. So it's 1 all over 2 raised to power 2. So the minus is no more there. Okay, now when you simplify this, if you simplify it properly, you end up discovering that what? 1 times 8 will give you 8, 0 times 4 is going to give you 0, 1 times 2 is going to give you 2, 1 times 1 is going to give you 1, 0 times half is going to give you 0, okay? Then 1 times 1 all over 2 raised to power 2 will give you 1 over 4. Because 2 raised to power 2 is 1 over 4, okay? So in that case, when you simplify further properly, okay, you're going to have 11 whole number 1 over 4, which is what? The conversion of 1011.01 base 2 to what? To denary numbers. So this end this type of question. So the other type of question I want to look at is known as what? BICIMAL numbers. Okay, this is a complete decimal. A complete what? Decimal. Is in base 10, but we want to convert it to what? To base 2. We call it BICIMAL numbers because it's actually what? A fractional part of the a number given. So in this case now, the first thing you need to consider is that you need to look at this. It's that BICIMAL number is a number in base 2 that involves a non-zero fractional part. A non-zero fractional part. Take note of that. Means the fractional part has to be what? Has to be non-zeros. Okay. So in that case now, what do you do? This is the hint. The hint. It said multiply continuously by 2, constant. Okay. and separate the whole and the decimal part by what? By a plus sign till the fractional part becomes 0. Below is an example. So look at this example now. It said multiply by 2 continuously. Multiply by 2, okay? Then you separate the whole from the fractional part. And take a look at what's going to happen. So if you have 2 all over 3 multiplied by 2, it's going to give you 4 over 3. When you have 4 over 3, when you divide it, it's going to give you 1. Okay? If you divide 4 by 3, it's going to give you 1. Then the remainder is going to be 1 over 3. Okay? If you know how to do fraction properly, if you sum this thing together, it's going to give you 4 over 3 back, right? So we're actually doing the right thing. So you have 1, then plus 1 over 3. So now you're going to do this thing, a kind of repetition, okay? We are going to go with what? With the remainder. So the remainder, which is 1 over 3, you go with it again. Still multiply by what? By that 2. That 2 is a constant, the one in yellow. So when you do that, it's going to give you 2 times 1 over 3. That's 2 times 1 is 2 all over 3. When you divide 2 by 3, we're going to assume is what? Is 0 because 3 cannot go into, isn't it? So it's going to give you 0. Then the remainder is plus 2 over 3 again. So we're taking the same value as the remainder. So again, you go with the remainder that you have now, which is 2 over 3. So when you have 2 over 3 times 2, it's like you're obtaining the first process, isn't it? This one now is like acting sinusoidally, okay? It's acting periodically. So that is how the question seems to be. But if you have subsequent questions that will come up, that is the same method you still apply. So you have 2 all over 3 multiplied by 2 is going to give you 4 over 3. When you divide this, give you 1, then plus 1 over 3, isn't it? If you repeat the same thing, you obtain the same value, isn't it? So you can repeat it again to obtain the same value. So you can stop anywhere since it's giving you a periodic result. So at this point, for you to obtain your answer, is that to obtain the answer, write out the number in white, okay? The numbers in white. You can see the numbers in white. You have 1, 0, 1, 0, 1, okay? Numbers in white, down as shown below, okay? You write it down as shown below, not like the other way around, okay? This one is like opposite of that, okay? You write this one down as shown below. So you have 1, 0, 1, 0, 1 as your final answer. So since the whole number aspect is actually not existing because you don't have a number before point, okay? So that number is going to just be 0 points, okay? So the value you're giving here is just a fraction, okay? Meaning that is a number after the decimal point. So when you finish doing it, you just put 0 point, the value you obtain, which is 10101 in base 2. Okay, I put this dot, a continuous dot there because this value is going to be continuous 1 if you continue doing this. That is the nature of the question, okay? So some question we have an end, but here it's not going to have an end. It's going to be a kind of periodic occurrence, okay? So you have 0.10101. So I hope this adds to our knowledge. This is BICIMAL numbers. Not everybody that knows this. So I believe this is going to help most of our students. So I hope this adds to our knowledge, and we hope to see you in next class. Have a nice day and keep on learning. Remember, our theme is what? Learning or knowledge is power. Without knowledge, the world remains what? Static. Have a nice day and thank you.